Welcome to the session on fractions, advanced addition and subtraction. Recall this example from a previous video. In order to add these fractions, we need to convert the fractions so that the denominators are the same. The denominators are 5 and 9. The lowest common multiple, or LCM, of 5 and 9 is 45. We're going to multiply the numerator and denominator of 4 over 5 by the same number 9 to give 4 over 5 equals 36 over 45. And similarly, we're going to multiply the numerator and denominator of 1 over 9 by the same number 5 to give 1 over 9 equals 5 over 45. Finally, we add the numerators to give 41. Of course, 36 plus 5 is 41. And we leave the denominators alone to give 45. Let's now try solving a more complicated fraction, as shown here, 1 over 6 plus 2 over 9 plus 1 over 18. In order to do this, we need to find the lowest common multiple of 6, 9 and 18. Recall that the acronym for the lowest common multiple is LCM. The LCM of two or more numbers is the smallest number among the common multiples. So, let's now try to find the LCM of 6, 9 and 18. The multiples of 6 are 6, 12, 18, 24 and so on. The multiples of 9 are 9, 18, 27, 36 and so on. And the multiples of 18 are 18, 36, 54, 72 and so on. The smallest common multiple of 6, 9 and 18 is 18. So, the LCM of 6, 9 and 18 is 18. We will now use the prime factorization method to find the LCM of four numbers up to 2 digits. So let's find the LCM of 8, 14, 16 and 34 using this method. First, find the prime factors of all the numbers. So 8 equals 2 times 2 times 2, 14 equals 2 times 7, 16 equals 2 times 2 times 2 times 2, and 34 equals 2 times 17. Now find the product of common prime factors in two or more numbers and non-common prime factors. The 2's shown are common to two or more numbers. So, place a 2 here. These 2's that are highlighted are also common to two or more numbers. And so we place a 2 here. And these 2's highlighted are also common to two or more numbers. So we place a 2 here. The product of common prime factors is 2 times 2 times 2. Now the 7, the 2 and the 17 are left on their own. Therefore, the product of non-common prime factors is 7 times 2 times 17. Now multiply all common and non-common prime factors. And therefore, LCM equals 8 times 238. Here we have the 8, and here we have the 238. to give us 1904. Now let's take a look at another example. We're required to find the LCM of 27, 36, 54 and 90. First, write down all the numbers as shown in the table. Divide the numbers by a number which divides at least two of the given numbers. So, we now write down the quotient of each number below it. 27 divided by 3 is 9. 36 divided by 3 is 12. 54 divided by 3 is 18. And 90 divided by 3 is 30. If the number is not divisible, then write it as it is, and keep dividing until the quotient is 1. Write down the quotient of each number below it. So 9 divided by 3 is 3. 12 divided by 3 is 4. 18 divided by 3 is 6. And 30 divided by 3 is 10. We are now going to continue to divide by 3 because at least two numbers in the last row divide by 3. 3 divided by 3 is 1. 4 divided by 3 needs to be left as 4 as it is indivisible by 3. 6 divided by 3 is 2. 10 divided by 3 needs to be left as 10 as it is indivisible by 3. We are now going to divide by 2 because at least two numbers in the last row divide by 2. 1 divided by 2 needs to be left as 1 as it is indivisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. And 10 divided by 2 is 5. Now divide by 2 as there is only a 2 and a 5 in the last row. 1 divided by 2 needs to be left as a 1 as it is indivisible by 2. 2 divided by 2 is 1. 1 divided by 2 needs to be left as it is indivisible by 2. And 5 divided by 2 needs to be left as a 5 as it is indivisible by 2. Now divide by 5 as there is only a 5 left in the last row. The rest are all 1s. 1 divided by 5 needs to be left as a 1 as it is indivisible by 5. Similarly for this one, and similarly for this one. However, 5 divided by 5 is 1, so we place a 1 here for a different reason. Now multiply the divisors to find the lowest common multiple, or LCM. So we have LCM equals 3 times 3 times 3 times 2 times 2 times 5, as shown here, which is equal to 540. Now let's take a look at another example. We're going to add these three fractions to each other. As before, we need to convert the fractions so the denominators are the same. The denominators are 2, 3 and 4, and the LCM of 2, 3 and 4 is 12. So the denominator of each fraction must be converted to 12. Let's do this. We're going to multiply the numerator and denominator of 1 over 2 by the same number 6 to give a half equals 6 over 12. Similarly, we're going to multiply the numerator and denominator of 2 over 3 by the same number 4 to give 2 over 3 equals 8 over 12. And finally, we're going to multiply the numerator and denominator of 1 over 4 by the same number 3 to give 1 over 4 equals 3 over 12. Now add the numerators 6, 8 and 3 to give 17. And leave the denominators alone to give 12. 17 out of 12 represents 17 pieces out of 12, so another way of expressing this is to say that we have 1 whole and 5 pieces out of 12, as shown here. Now let's take a look at another example. Let's find this. As before, we need to convert the fractions so the denominators are the same. The denominators are 2, 5 and 4. The LCM of 2, 5 and 4 is 20. So the denominator of each fraction must be converted to 20. We multiply the numerator and denominator of 1 out of 2 by the same number 10 to give 1 out of 2 equals 10 out of 20. We multiply the numerator and denominator of 2 out of 5 by 4 to give 2 out of 5 equals 8 out of 20. And similarly, we multiply the numerator and denominator of 1 over 4 by the same number 5 to give 1 over 4 equals 5 out of 20. Now add and subtract the numerators as shown. So 10 minus 8 plus 5 gives us 7. And we leave the denominators alone to give 20. And so we have 7 over 20. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time so you can check your answers as you go along. Pause the slideshow whenever you need to. Now have a go at these exercises. Again, the solutions will be released one at a time so you can check your answers as you go along. Pause the slideshow whenever you need to. And now for these exercises. Again, pause the slideshow whenever you need to. This brings us to the end of this session. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic. Thank you very much for listening.